equivalent fractions. So we'll be learning new techniques to simplify expressions, and we use this particular fact that fractions can be presented in different form, and this form is up to us to choose. Observe that, for example, this fraction on the left-hand side is in fact 2/5. So that's the same value, but in different form. And basically what we're going to use, that's properties of fractions. So if we have a fraction a/b, if we multiply it on the same number and divide on the same number, then we practically don't change the value of that fraction, because essentially what we did, we multiply a and b on 1. c/c is 1. So we're going to use this property so we can simplify our expression. First of all, I have to mention that once we have the same term in both numerator and denominator, we assume it's not 0 and then we can cancel out. But we can apply this technique if and only if we have multiplication throughout. So no pluses, minuses, not in numerator, not in denominator. Okay, let's consider the examples. So first step would be factorize numerator and denominator. Hopefully that will produce same common factor in both numerator and denominator, which we can cancel. All right, deal with one thing at a time. So numerator, let's factorize it. The common factor would be x². Yep, so what's left in a bracket? So from the first term we have x minus 2. So we factorize our numerator. Denominator, okay, we have x² minus 4, which is 2². Hence we can apply difference of squares formula, which is x plus the second term, which is 2, x minus second term, which is 2. So what happened, first of all, we have multiplication, well, and division throughout, and we got same factor on numerator and denominator. Hence we can cancel out, just like here. So because we have x minus 2 divided over x minus 2, which is 1. And what's left is x² over x plus 2, which is simpler expression. Okay, next example. Again, we have some sort of addition subtraction in both numerator and denominator, so we have to factorize them first. Let's deal with numerator. As I said, those special products, you should be able to recognize them both from right to left and left to right. So this looks like a square of the difference. Okay, look, x² minus, this can be presented as 2 times 3 times x. Yep, so if it is in fact complete square, we will have 3², and that's exactly what 9 is. Yep. So now I know how to factorize this. Denominator. This is difference of two squares, x² minus 9, which is 3². So I use the formula. I use my special product result. Well, now I have to factorize numerator. That would be simply x minus 3 squared over x minus 3 times x plus 3. Okay, so look what I have. I have a numerator, I have x minus 3 to the power of 2 and x minus 3 to the power of 1 in denominator. So x minus 3 is a common factor, which I can cancel out. So I will have x minus 3 to the power of 1 in numerator and just 1 in denominator. And what's my final result is x minus 3 over x plus 3. Again, that looks simpler than this rational fraction. Okay, this simple example, in fact, is tricky, and a lot of people does mistakes in examples like this. In fact, you can't do anything, nothing. You can't cancel out anything because you don't have multiplication for that. So it stays as it is. You can't cancel out anything. So I'll write it cannot cancel. So you can't do anything, so it stays as it is. And the third example, again, seems to be simple, but not as such. Okay, numerator, x squared minus 25, it's difference of two squares, x squared minus 5 squared. Okay, factorizing, that would be x minus 5, x plus 5. Okay, this term looks pretty much like the one we have in denominator, but the sign is different. Beware. I'll present 5 minus x in the form minus 1 on x minus 5. Yeah, so it's exactly the same thing. So minus x minus on minus 5 gives us 5. So it's exactly 5 minus x presented in different form. So what I've done, I presented my numerator in a form which gives me exactly the same factor which I have in numerator. So this is the same factor. So x minus 5 divided by x minus 5 is 1. And we simplify our expression. The final result would be, don't forget this minus x plus 5. I'll rewrite it and expand those brackets. It would be minus x minus 5. Don't forget the sign. More examples on basically equivalent fractions and how we use them when we multiply and divide fractions. Okay, basically when we multiply fractions like here, what we do? We multiply numerators and we multiply denominators. So that would be simply 2x times 4, 7 times 3, and that is 8x over 21. So in general, the rule is a over b times c over d equals what? ac over bd. Yep, so numerators multiplied, denominators multiplied. That's slightly different story when we have one rational fraction divided by another one. So the rule would be, so if we divide, first we reduce this case to multiplication of fractions. So in this case, if we divide on c over d, that equivalent to a over b multiplied on reciprocal of that rational fraction, as sometimes you say flip it over. So reciprocal would be when you change numerator and denominator. That would be d over c, and then proceed as usual. So we apply this rule to the second example. So 2x over 7, that division 2 by the way, divided by 3/5, it's the same as 2x over 7 multiplied on reciprocal of 3/5, which is 5/3. And then we can complete our example by multiplying numerators, that give you 10x, over product of denominators, which is 21. The last example is a bit tricky, so make sure that you do one step at a time and don't try to do too many things, you'll make mistakes. So one step at a time. First, observe that one rational fraction is divided by another. First step would be replace it by multiplication. So I'll just rewrite it. 4 minus x squared over x squared minus 3x plus 2 multiplied by x squared minus 9 over x plus 2. Now, Well, obviously our goal is to simplify this. So first I'll write complete the multiplication. So it would be just 4 minus x squared times x squared minus 9 over x squared minus 3x plus 2 times x plus 2. Now we try to factorize each of the terms and hope that we get some common terms in both numerator and denominator, which we can cancel out. So this term can be factorized using the difference of 2 squared. 4 is 2 squared, hence applying the formula we'll have 2 minus x, 2 plus x. I will leave x squared minus 9 as it is for the moment, and I'll factorize it if I need to. Now, this trinomial, we used this technique before, so we have to look, to factorize it, we have to look for two numbers which gives us, in a product gives us 2, and in a sum gives us minus 3, and that's simply minus 1 and minus 2. So to factorize it, we have x minus 1 on x minus 2, and then we have x plus 2. Excellent. So we completely factorized everything except this term, but maybe we don't need to. So can we now cancel out something? Yes. For example, 2 plus x is the same as x plus 2, so we cancel it out, 1 and 1 here. However, 2 minus x has an opposite sign to that of x minus 2. So I'll rewrite the terms in exactly the same form first. So 2 minus x is minus 1 times x minus 2. And then we have x squared minus 9 over x minus 1, x minus 2. So now I have exactly the same terms in both numerator and denominator, can cancel them out. And to finalize, I'll remember this minus 1. Yep, so minus 1 times x squared minus 9. That gives me the following. Minus x squared plus 9, that would be my numerator, over x minus 1, that would be my denominator, and I can't simplify it further.